the end of last class, we had talked about the handy microservice, which is very important for implementing the assignment 2C, especially the multi-quote repository. Now we're going to turn our attention to the Zippy microservice structure and functionality and talk about that because it gives us a different perspective on how to organize persistence in a microservice-based application. So we're going to talk about how the Zippy controller and Zippy service and Zippy application and so on use the Jakarta Persistence API. Except we're going to do something kind of funky here. We're going to have the interface to the controller use reactive types, but we're going to have the implementation of the repository use classic Java types. And we'll talk about the strategy involved here and the pros and cons of doing things in this way. So first, let's just take a real quick look at the Zippy application. This is very similar to what we did for the handy application. As you can see, that's the entry point into the Spring WebMVC-based version of the Zippy microservice. So this is actually using Spring WebFlux, but you'll see under the hood it uses some of the synchronous behaviors that we would expect from Spring WebMVC. We extend the base application, so we get this run method. We'll talk about that in a second. We've got some annotations here. These annotations are designed so we can use the Java Jakarta Persistence API, the JPA, instead of R2DBC. And then this is the method that we call that arranges to run the Zippy microservice with the Eureka discovery service with the name that's relevant here. Let's talk about the Zippy controller. This is going to look very familiar with just a little tweak on what we talked about when we had covered this back in an earlier lesson where we were talking about pure Spring WebMVC approaches with the JPA. As before, we auto-wire a couple of things. We auto-wire this application context and the Zippy service. You've seen that before. We do this so that the Eureka discovery service can automatically determine whether or not our Zippy microservice is alive and kicking. And it does that by making a call to the Zippy route name, and that will go ahead and end up calling this method, which will return the fact that it's alive, which is good. We've got a bunch of methods that are the controller endpoint handler methods that convert from HTTP requests, get and put requests into Java native types. So here you can see we've got get all quotes, post quotes, search, and so on. There's some other stuff I omitted here. Everything returns a flux. That's a little different from what we looked at last time when everything returned a list. We'll talk more about that in just a moment. We use the get mapping and post mapping stuff along with the other annotations like request body. This is all very similar to what we had before, just using fluxes, not lists. And then let's take a quick look at the Zippy service. So this, of course, as always, defines the implementation of everything. We're going to annotate it with service. We're going to auto-wire the Zippy quote repository. And that's what we're going to look at here in just a moment after we look at this part of the code. The service methods are all pretty standard. They look very similar to what we looked at before, just Java calls that are forwarded from the controller. The difference being that they're returning the Flux reactive types as opposed to lists, and we'll talk about that in a second. As you can see, they're making calls to the Zippy quote repository to do synchronous JPA invocations to get the access in a synchronous way. And you'll notice if you were to look at these implementations, all these calls return lists of quotes that match whatever we were querying or looking things up by. This method here does a little bit more processing. We'll take a look at that when we walk through the code. It's very similar to your database method that does the same kind of thing. And this is the part that differs. So here we're going to take the results that come back from the synchronous calls on the JPA methods, which return lists, and we're going to convert them into fluxes. So you can see in every case we use the from iterable factory method, and if you recall from iterable, it takes an iterable, which is what a list is in Java, and it converts it into a flux. Now, the nice part about this is we could pretty much reuse wholesale all of our JPA implementation from the earlier WebMVC version of the code. And then we just write this little adapter that turns it into a flux. So the nice part was not a whole lot changed. We didn't have to do some of the stuff that we did with the handy microservice, where we had to implement things using R2DBC2, or R2DBC. However, this approach is more limited because it doesn't give you the full benefits of reactive programming. In particular, these calls need to be made, and this server will block synchronously until those calls are finished, and then from iterable converts the list into a flux. Whereas with the R2DBC version we did for the handy microservice, it was fluxes all the way down. So the minute that we made the call, it called into the R2DBC implementation of these various query methods, and those would let the service and the controller return the flux immediately back to the caller while the processing was taking place to query the database asynchronously on the server side. So that's where it gets just a little bit different from what we saw before. So key thing to remember with this example, it's easy to implement because we can reuse the Spring WebMVC stuff. However, the downside is it is not as fully asynchronous as the R2DBC handy microservice. And that's why I wanted to show you both different ways of doing that, because you'll get a better sense of the trade-offs. Okay, so that's the end of part one of this lesson.